This next one requires a tad bit of care with the geometry work that we will foresee here. So just be aware if your geometry is not happy with you at the moment, this might be a little tricky. So we have a particle of charge Q is traveling at a constant speed v along the x-axis. Calculate the total power passing through the plane x equal a at the moment the particle itself is at the origin. Okay, so power passing through. If you see power, you should automatically think, okay, I need the pointing vector. Okay, so automatically go, okay, power pointing. Now I get the scope of what I need. Okay, so of course let's doodle this out. We have a point charge Q going down the x-axis, and what we see is that the power radiated. We see the field for R, and at some length away A is going to be projecting through at some radius R in the plane with some circle, the nature of these fields. I'll just give you a moment to ingest that, but we'll see why this was needed when we talk about the pointing vector now. The power crossing the plane, okay, is equal to P is equal to the integral of S dot dA. Here, the S is equal to 1 over mu naught E cross B, which we already know that B is equal to 1 over C squared V cross B. So now we're left with a triple product. So let's call in our old friend BATCAB, vector identity. We like that. Since that C squared is given in the formula for B, let's go ahead and change it out for a mu naught epsilon naught and cancel the mu naughts. As we apply the BATCAB, we get V E dot E and then minus E dot V. That being said, we can make quick work now, I believe. But the integral might be a little hairy, so let's be careful. So if we're looking at the in the plane, we go from 0 to pi because we're on the circle, and R can extend from 0 to infinity. Okay, here we have epsilon naught E squared V minus, now the velocity is only traveling in the x direction, so we only need the x component of the E field in the dot product. Hence we get E squared V minus EX V E dotted with the dA, which is R dr dphi in the x hat direction. Okay, let's go ahead and be careful how we approach this now, because epsilon naught is a constant, push it out front. The dphi integral gives us a 2 pi. We've seen that a million times already. But now that dot product with the x hat needs to go to the V on the first term in the bracket and the E on the second term in the bracket. Okay, and then R dr. What we see here is that V dot x, well, that just gives us V. Okay, nothing surprising there. And then E dot x gives us EX again, so we get EX squared there. Again, should not at all be that worrisome in how we deal with this. We've seen it before. Now that we have V in both of them, we know that is independent of R, so we factored out the integral. And we're still left with 0 to infinity of E squared, but we know that EX is just the cosine of that angle, hence what we saw in the diagram. So EX is just E cosine theta, and we square it. That being said, both terms have an E squared in it, so we factor that out. Lo and behold, we're left with a 1 minus cosine squared, which goes to sine squared. Okay? And now is where the magic begins. Okay? So, with that, we know that E is equal to Q over 4 pi epsilon naught, and we see that for this point charge moving at constant velocity, we get 1 over V over C squared, which we'll call 1 over gamma squared. That gamma, again, will come back again and again and again. Similarly, in the denominator, we have that 1 minus V over C squared, sine squared theta to the 3s power. Again, R hat and R squared are accompanying that. So if we take E squared, then we have the dot product of E with itself, and then we get a lot of square terms here. So, yeah, let's be careful with that. We square everything that we can. That bracket goes from 3 halves to 3. R goes from R squared to R fourth. That 1 over gamma squared is squared, and the Q over 4 pi epsilon naught squared is squared. Cool. Got that there. Geometrically, though, we know that the radius AR is related to the length A times tangent theta. Okay, just look at the diagram. The reason why we do this is now we want to put everything in terms of the d theta in order to get rid of that sign that we have in the integrand. Okay, so dr is just A over, well, we know that the definition from tangent, taking that derivative will give us 1 over cosine squared d theta. Nothing really upsetting there in my opinion, because it goes to secant squared, which is 1 over cosine squared, so I'll just, blast it through that. And geometrically, we also know that cosine theta is equal to A over big R. Okay, so what we saw a few questions ago is we substituted in similarly like this for a simplification. So I forget which question exactly, so I'll have to go find it for you. Let me make a note of that. But, we saw this before. Okay, we saw it before. Okay. So we just plug everything in. I tried color coding it as best I could. E squared is equal to that. Sine squared came from the territory once we substituted in. We have to be aware now that if we change the limit from r going from 0 to infinity in the substitution, well, we know that 0 to pi gives us everything we need on that side with the tangent. So I think we're okay, at least with that substitution. Tangent, we're going to switch to a sine and a cosine. That's why it's highlighted in red. And then the, plug in dr, and we get A cosine squared d theta. And now it's just a whole matter of simplifying everything that we could possibly simplify. Okay, that is gross, grossity gross, a whole lot of gross. Okay. We get a sine cubed from the sine squared and the red, and we have a cosine cubed. So we got to be careful with both of those. Take out everything that you possibly can as far as simplifying down these constants. You see that r to the fourth in the bottom yields to a lot of havoc. So whenever we're dividing by a fraction, we multiply by the reciprocal, and we see that most of those things cancel. All in all, what we're left with after a bunch of cancellations of random things is v q squared over 8 pi epsilon naught gamma to the fourth 1 over a squared integral 0 to pi over 2 sine cubed cosine theta over the 1 minus v divided by c squared sine squared theta all cubed d theta. If we let the u equals sine squared, du equal all this, we see that it's just a mess. And what we have to be aware of here is that we could use tables to help us with this. The u sub is pretty easy, I believe, to see. The du is pretty easy. So you don't need too much, but just be very careful that you're doing another substitution, change the bounds again, and evaluate through. That being said, we get a gamma to the fourth because of the 1 over v c squared. Okay. That goes to gamma to the fourth over 2. We like that. The gammas cancel, and we see that we have power is equal to v q squared over 32 pi epsilon naught a squared. And let me tell you, this will come back again in chapter 11, and you're going to be in for a joyous adventure.